Take a moment to look around you. Look at the coffee cup sitting motionless on your desk. Look at the trees standing rigid outside your window. Everything seems peaceful. Everything seems solid. But this stillness is the greatest illusion in the universe. It is a trick played on your senses by gravity and relativity. Right now, you are standing on the surface of a massive sphere of rock, iron, and water. And this sphere is not sitting idle. It is a carousel spinning in the dark, performing a cosmic ballet that has lasted for eons. At the equator, the Earth is rotating at a speed of roughly 1,040 miles per hour. That is 1,670 kilometers per hour. To put that into perspective, that is almost twice the cruising speed of a commercial jetliner. It is faster than the speed of sound. Even the fastest bullet trains in Japan or Europe don't come close to a fraction of this velocity. Even if you are currently sitting in New York, London, or Tokyo, far from the equator, you are still moving at hundreds of miles per hour, right this second. You are hurtling eastward without even realizing it. You don't feel it for the same reason you don't feel the speed of an airplane while you're sitting in your seat with your eyes closed. You, the atmosphere, the oceans, the skyscrapers, and the bedrock are all moving together. It is a synchronized dance of momentum that has continued uninterrupted for 4.5 billion years. But what if the music stopped? Not forever, just for a moment. What if, for just 5 seconds, the Earth's crust slammed on the brakes? What if the ground beneath your feet instantly froze in place, locked in a static position relative to the sun, while the atmosphere and everything else kept their existing momentum? It sounds like a short interruption. 5 seconds. You can hold your breath for 5 seconds. You can blink. It feels insignificant in the span of a human life. But in the laws of physics, 5 seconds is an eternity. If the Earth stopped for 5 seconds, it wouldn't just be a bad day. It would be the most violent, energetic, and destructive event since the Theia impact that formed our moon. Today, we are going to simulate this apocalypse. We will analyze the physics, the geology, the meteorology, and the sheer biological horror of what would happen. We will travel from the equator to the poles, from the bottom of the Mariana Trench to the cruising altitude of a 747, to answer the ultimate question: who lives, who dies, and what is left of our world when the spinning starts again? Welcome to the simulation. To understand the immediate horror of the first second, we must look to Sir Isaac Newton, specifically his first law of motion, the law of inertia. It states that an object in motion will stay in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This isn't just a rule, it is the fundamental architecture of reality. Think of it like a car crash. You are driving down the highway at 60 miles per hour. Your car hits a solid concrete wall and stops instantly. But you do not stop. Your body still possesses the momentum of traveling at 60 miles per hour. You continue flying forward until the seatbelt, the airbag, or the windshield exerts enough force to stop you. The damage comes not from the speed, but from the sudden change in that speed. Now, scale this up to a planetary level. The Earth is the car. You, the buildings, the oceans, and the trees are the passengers. And the Earth has just hit the cosmic wall. Let's start our observation at the equator, places like Brazil, Kenya, Indonesia, or Singapore. Here, the rotational speed is at its maximum, roughly 1,000 miles per hour. The centrifugal force here is strongest. At the exact moment the ground stops, everything not chemically bonded to the bedrock is instantly transformed into a supersonic projectile. If you were standing on a beach in Ecuador, you wouldn't just fall over. You would be launched eastward at a speed of Mach 1.3. That is faster than a standard 9mm bullet fired from a handgun. Your body would essentially disintegrate upon impact with the air itself, or any obstacle in your path. The G-force alone would be enough to separate your flesh from your bones before you even hit the ground. But it's not just you. Cars, trucks, ships, and loose rocks would all be hurled east at supersonic speeds. Imagine a modern metropolis like Singapore. The skyscrapers are anchored to the ground. The ground stops, but the top of the building and everything inside it wants to keep moving at 1,000 miles per hour. The result is not a structural collapse like a controlled demolition. It is a shearing. Every structure would be ripped from its foundation and shredded instantly at the base. Consider the energy involved here. Kinetic energy increases with the square of velocity. A crash at 1,000 miles per hour carries 100 times the energy of a crash at 100 miles per hour. At this speed, solid materials behave like fluids. Steel doesn't bend, it splashes. The debris field from a single city would possess the kinetic energy of a small nuclear arsenal, scouring the landscape behind it. The very air around these moving objects would compress so rapidly that it would glow, creating a shock front of superheated gas leading the wave of destruction. Ancient monuments like the pyramids of Giza, which have stood for millennia, would be atomized in a fraction of a second, turned into a supersonic sandstorm that would scour North Africa down to the bedrock. Concrete and steel would turn into a cloud of shrapnel moving faster than sound, decimating everything in its trajectory. It would look less like an earthquake and more like a planetary blender. Now, let's move away from the equator. Let's go to the United States or Europe. At roughly 40 to 50 degrees latitude, think New York, Madrid, or Beijing, the speed is lower because the distance to the axis of rotation is shorter. But lower is relative. Here, the ground is moving at about 700 to 800 miles per hour. While this is technically subsonic, the result is practically the same. Human beings are not designed to survive impacts at 700 miles per hour. You would be thrown against the nearest wall with a force that would liquefy your internal organs instantly. In less than 1 second, the human population of the Earth would be reduced by more than 99%. But is anyone safe? Mathematically, yes. If you were standing exactly on the North Pole or the South Pole, the rotational speed is effectively zero. You are simply pivoting in place. If the Earth stopped spinning there, you might feel a slight lurch. You might lose your balance and fall into the snow, but you wouldn't be turned into a projectile. However, don't celebrate yet. Just because you survived the first second doesn't mean you will survive the next 4. Because while the solids have crashed, the fluids are just getting started. We often forget that air has mass. It feels weightless to us, but it is a physical substance. A cubic meter of air weighs about 1.2 kilograms. Multiply that by the entire atmosphere, and you have billions of tons of gas. When the Earth stops, the atmosphere does not. The atmosphere continues to rotate at its original speed due to inertia. This means that relative to the now stationary ground, the wind suddenly picks up to 1,000 miles per hour instantly. Let's put that number in context. A Category 5 hurricane, the most destructive storm classification we have, has sustained winds starting at 157 miles per hour. The strongest wind gust ever recorded on Earth was 253 miles per hour during a cyclone. The wind created by this event is 4 times faster than the strongest wind ever known to man. This is not a wind. This is a shock wave. This is an atomic blast wave without the radiation, rolling across the entire surface of the planet. This wall of air moves faster than the speed of sound, creating a continuous sonic boom that would circle the globe. This wind would scour the surface of the Earth clean. Any forest that wasn't flattened by the initial inertia would be ripped from the soil. The soil itself would be stripped down to the bedrock, creating a dust storm of planetary proportions. But here is where the physics gets truly terrifying: friction and aerodynamic heating. When air moves this fast over the ground, the friction is immense. Think of a spacecraft re-entering the atmosphere. It heats up not because of rocket fuel, but because of the compression and friction of the air molecules slamming into it. At ground level, this supersonic wind would generate massive amounts of kinetic heat. The air temperature would spike instantly. It wouldn't just blow things away, it would bake them. Massive global flash fires would ignite within seconds, but they wouldn't look like normal fires. The wind would stretch the flames into long, horizontal jets of plasma, scorching everything in their path like a blowtorch. And what about the sound? The noise of a global supersonic wind hitting mountains, buildings, and forests would be deafening. The decibel level would be far beyond the threshold of pain. It would likely rupture the eardrums of anyone hiding in a bunker near the surface. The pressure differential alone, the sudden drop in pressure on the leeward side of mountains, would be enough to cause buildings to explode outward and lungs to collapse. If you were in a passenger plane, cruising at 35,000 feet, you might think you are safe. You are already in the air, moving with the atmosphere, right? Wrong. The atmosphere you are flying through has just turned into a chaotic, turbulent nightmare. The navigation systems rely on GPS and ground speed calculations that are no longer valid. But more importantly, the sudden shift in atmospheric flow, reacting to the mountains below, would create vertical shears, columns of air moving up and down at extreme speeds. These forces would snap the wings off a Boeing 747 like it was a dry toothpick. Airplanes would fall from the sky like rain, disintegrated by turbulence before they even hit the ground. So, the land is scoured, the air is on fire. But the most massive object on Earth, the one that covers 70% of the surface, is about to make its move. Water is heavy. A cubic meter of water weighs a metric ton. And right now, billions of tons of ocean water are moving east. When the Earth stops, the Pacific, the Atlantic, and the Indian Oceans don't just sit there. They continue their momentum with relentless force. Imagine running with a shallow tray of water and stopping abruptly. The water flies forward, spilling over the edge. On a planetary scale, this creates a mega tsunami that defies imagination. This is not a wave. A wave breaks and recedes. This is the entire ocean simply sliding off its bed. A wall of water, kilometers high, would crash onto the east coasts of every continent. Japan would be submerged instantly, erased from the map. The east coast of the United States, gone. The water would rush inland for hundreds of miles, smashing over the Appalachian Mountains. The continental shelf would act as a ramp, launching this water deep into the heartland. Conversely, on the west coasts, the ocean would retreat at supersonic speeds, leaving the seafloor exposed for miles, revealing shipwrecks and trenches before eventually sloshing back with catastrophic force. But there is a second, even stranger phenomenon that would happen with the water. And this involves the shape of the Earth itself. The Earth is not a perfect sphere. It is an oblate spheroid. It bulges at the middle due to its rotation. Because the Earth spins, centrifugal force pushes the oceans toward the equator. Basically, there is a hump of water around the equator that is held there by the spin. The sea level at the equator is roughly 8 kilometers higher, measured from the center of the Earth, than it would be if the Earth weren't spinning. The moment the spinning stops, that centrifugal force vanishes. Gravity becomes the only ruler, and gravity wants that water to be level. Suddenly, that massive equatorial bulge of water has nothing holding it in place. It begins to rush toward the poles where the gravitational pull is effectively stronger without the counteracting spin. As this water rushes polarward, it wouldn't be a smooth tide. It would encounter the complex topography of the ocean floor, underwater cliffs, canyons, and ridges. This would create turbulence and whirlpools the size of small countries, capable of dragging anything on the surface down into the abyss. The sheer weight of this shifting water, trillions of tons moving from the equator to the poles, would actually alter the Earth's center of mass, causing the planet to wobble in space like an unbalanced top. The pressure at the poles would increase drastically as the ocean depth multiplied. This immense new weight would likely fracture the ice caps of Antarctica and Greenland from below, sending continent-sized icebergs careening into the flooding cities of the southern hemisphere, turning the new polar oceans into a grinding field of ice and debris. So, you have two apocalyptic water events happening at once: the inertial tsunami crashing eastward, destroying coastlines, and the gravitational redistribution rushing north and south, drowning the hemispheres. The oceans would flee the equator. The northern parts of Europe, Russia, Canada, and Greenland would be flooded by a global tide rising miles into the air. The southern parts of South America, Africa, and Australia would face the same fate. Ironically, the equator might briefly become dry land, a ring of exposed seabed stretching around the world, before the sloshing water returns in a chaotic, muddy fury. This redistribution of water is so massive that it would actually change the weight balance of the Earth's crust. And that brings us to the next nightmare: the ground itself. We treat the ground as solid, but to a physicist, the Earth is just a thin shell floating on a liquid center. The crust is solid rock, varying from 5 to 70 kilometers thick. The mantle beneath it is viscous rock. The outer core is liquid iron. All of these layers rotate together in harmony. When the crust stops for these 5 seconds, the interior of the Earth does not. The mantle and core keep spinning. This creates a massive friction differential between the frozen crust and the spinning molten rock underneath it. The stress on the tectonic plates would be incalculable. It would be like trying to stop a spinning car wheel by grabbing it with your bare hands. This sheer force would shatter the Earth's crust like an eggshell. We are not talking about standard earthquakes. The Richter scale creates a logarithmic measurement of energy. A magnitude 9 earthquake is devastating. The breaking of the Earth would trigger seismic events that would effectively be magnitude 12 or 13, a category that seismologists don't even use because it implies the planet is breaking apart. Every fault line on Earth would rupture simultaneously. The San Andreas Fault, the Ring of Fire, they would unzip instantly. Volcanoes that have been dormant for thousands of years would erupt explosively as the pressure from the spinning mantle seeks a way out. New volcanoes would rip open in the middle of stable continents, spewing magma where there was once farmland. Supervolcanoes like Yellowstone could be triggered, spewing enough ash into the atmosphere to block out the sun for a decade. The very shape of the continents would change. The land would liquefy through a process called soil liquefaction, swallowing cities whole. If you were in a deep underground bunker, perhaps the only place safe from the wind and the water, you would now be crushed by the bunker itself, or roasted by the heat of the friction penetrating the crust. The sound of the earth cracking would be a low-frequency rumble, an infrasound that would vibrate through your very bones. So, let's recap the first 4 seconds. The surface is scrubbed by supersonic winds. The air is superheated plasma. The oceans have swallowed the continents. The ground is shattered by global earthquakes. And then, the 5 seconds are up. Time is up. Whatever cosmic hand held the Earth still now releases it. The planet must return to its rotation. It accelerates back to its original speed to conserve angular momentum. You might think, the worst is over. The movement is back. You would be wrong. The restart is the double tap. It is the whiplash. When the Earth stops, everything flies east. When the Earth starts spinning again, it has to accelerate the crust underneath the chaotic mess that remains. This creates a violent jerk in the opposite direction. The water and debris that was rushing toward the poles? It is now violently thrown back toward the equator by the return of centrifugal force. The winds that were slowing down? They are whipped up into new patterns of turbulence. This sudden reacceleration would add more stress to the already shattered tectonic plates. Whatever buildings or mountains miraculously survived the stop would likely crumble during the restart. The oceans, confused by the conflicting forces of inertia and gravity, would turn into a global washing machine, churning mud, debris, and cities into a toxic sludge. The atmosphere would take weeks, perhaps months, to stabilize. The Coriolis effect, which helps steer our weather, would be erratic as the atmosphere struggles to catch up with the ground. Hypercanes, storms with the size of continents, would rage across the planet, fueled by the heat of the friction and the warm oceans. The sky would be dark, filled with volcanic ash, smoke from the global fires, and vaporized seawater. When the sun finally breaks through the clouds of ash and smoke, weeks later, what does the Earth look like? From space, the blue marble would look bruised. Brown and gray swirls would cover the vibrant greens and blues we know. The coastlines would be unrecognizable. Florida might be gone. The British Isles reshaped. Japan might be reduced to a series of rocky peaks jutting out of a muddy sea. Is anyone alive? The human race, effectively, is extinct. Perhaps a few lucky souls in the Amundsen-Scott South Pole Station survived the initial jerk, as they were at the axis of rotation. But their station is likely damaged. Their communication with the outside world is met with static. They are alone on a dying planet, with limited food and no way to leave, waiting for the encroaching cold. Submarines deep in the ocean might have survived the surface waves, but the shock waves from the sound of the breaking event could have crushed their hulls. If they survived, they would surface to a world that has been erased. No ports to dock at, no command structure to report to. The only things that remain untouched are the artifacts we left in orbit. The satellites, the GPS network, the communication satellites, the International Space Station. They continue to orbit, looking down on a silent world. The astronauts on the ISS would have watched the horror unfold in real time, helpless witnesses to the end of history. They would be the last humans, drifting in the void. Life on Earth would eventually recover. Microbes deep in the crust, bacteria in the deep ocean vents. They would survive. Evolution would press the reset button. In a few million years, the planet would be green again. New creatures would roam the forests. The scars would heal. But there would be no statues of us, no libraries, no internet. just a thin layer of strange plastic sediment in the geological record, marking that we were once here. This scenario, of course, is impossible. Momentum is a conserved quantity. The Earth cannot just stop without a force equal to its spin acting upon it. But this thought experiment serves a purpose. It reminds us of our fragility. It reminds us of how lucky we are. We walk around feeling like masters of our domain. We build static cities on a dynamic rock. We forget that we are clinging to the surface of a spaceship that is hurtling through the void at terrifying speeds. Our survival depends entirely on the stability of these cosmic forces. We rely on the spin to regulate our days, our weather, and our oceans. We rely on the momentum to keep the atmosphere breathable. So the next time you feel a gentle breeze, or watch the waves lap against the shore, take a moment to appreciate the motion. Be thankful that the dance continues. Be thankful for the inertia that keeps your coffee in your cup. Because if the music ever stops, so do we. Thank you for watching. If you want to see us simulate a supernova hitting the solar system, or what would happen if the moon suddenly disappeared, let us know in the comments below. Don't forget to like, subscribe, and hit the bell icon so you never miss a journey into the unknown. I'll see you in the next one.